So we are going to be talking about water availability today. So this is section 1.4. Vital for all life. So when they go discover new planets, they're looking for water because we believe that water is essential to life because we've seen on our planet that water is essential to life. Moderates climate. So if there's water in the environment, it can help keep our temperatures more stable. So if you've ever been to a desert or know this about a desert, the temperature changes rapidly because it's not very moist there. So it'll be very, 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 very hot, and then it'll become very cold at night. And when you have more moisture, you have a more moderate climate. It doesn't go to as many extremes. Sculpts the land, so things like a canyon, all of those things happen because water is breaking away at the land. Removes and dilutes waste and pollutants. That's inside of our body. That's also in nature, so it keeps water flowing, and that there prevents a buildup of a dangerous thing, like in the soil, for example, if there's enough water. And it's what's constantly moving through the hydrologic cycle, moving things around the world, moving water itself. So it's very, very, very important. Okay, so this here we have an image. That large blue dot is over the western side of the United States. That is actually representing all the water in the world. Okay, and all of that water in the world can fit kind of on a western United States. Then we have a larger dot, than the smallest, but then we have the largest, then the medium size. That is all fresh water, liquid fresh water that we have access to. So that's swamps, rivers, lakes, and then the smallest dot over Georgia is actually what is in rivers and lakes that we are really accessing. So the medium dot is groundwater, swamps, rivers, and lakes, and then we have our really tiny one, which is our lakes and rivers that we actually have access to, that we need as fresh water in the whole world, not just in the United States. So this is when you're going to need colored pencils, and you're going to maybe want to stop the video at a certain point to actually color this in. So the distribution of Earth's water, our first column that we're going to look at on the left is total global water, and you can round these percents to make it a little bit simpler, and obviously it's not going to look perfect in your diagram when you're drawing, but it's important to include. So oceans are about 96.5% of total global water. You might want to round that up to 97 to make it a little bit simpler. Saline lakes, so salt lakes, are 0.07%, rounded up to 0.1%, that's fine. And then we have saline groundwater, so salt groundwater. And then we have fresh water. So salt groundwater is at 0.93%. It's fine to round that up to 1%. And then fresh water at 2.5% is that's remaining. And that's the stuff we need, right? Salt water is obviously essential for organisms that live in it. For us, we need access to fresh water. So you're going to pause the video, color in the parts that you need, and it really shows you how much is actually available to us of the earth. Not that much. The next one that you are coloring in is, well, where is the fresh water, right? So we have that much fresh water, but how much of it on the earth is accessible to us? So we have glaciers and ice caps make up about 68.6%, round to 69% of fresh water. Again, we don't really have access to that, right? It's frozen, so we do not have true access. Groundwater, which we have a level of access, that's how we get wells and all that kind of stuff, is 30%. And then the easiest access water is surface water and other fresh water at 1.3%. And again, you can round these numbers. So it kind of shows you how much. We only had 2.5% of all the water, and then even a tinier amount is those surface waters that we really access to begin with. Again, make sure you're coloring this in and rounding. Then our last one is surface water and other fresh water. So where is all of this? A little bit more complicated, right? We see a lot more lines. Ice and snow, 73%. Lakes, 20%. And then we get into more complicated things. Again, we are more than welcome to round. Atmospheric water at 0.2. Biological water at 0.2. Rivers, 0.5. 0.46, rounding to 0.5. Swamps and marshes at 2.5. And then soil moisture at 3.5. Okay, so most of it, again, is in ice and snow, not as accessible to us. Also, we need to kind of keep it there because it is important. lakes at 20%, and then we have all these like tiny little numbers that, and you think like atmospheric water would be more, right? Like it rains, it's so annoying, but it is such a small percent. And remember, we're looking at a percent of a percent when we're talking about this. Only about 0.02% of the Earth's water supply is available to us as liquid fresh water. So just to keep that in mind, not a lot. And that's going to go in that bubble on the bottom of your page. So you should have finished coloring in. If you didn't, jump back and color. You guys are going to read an article. Here's where the post-apocalyptic water wars will be fought. That is posted for you, the link, so you guys will go to that as well. Now, using this water cycle diagram, you are going to be filling in the chart that says flows and throughputs. So we kind of jump down to color in. So you're going to use this and say, okay, well, what's the transfer process? Transformation process, so the phase change, and then other human effects that might be listed, and we will add some in class as well. And then lastly, you're going to add where are the stock storages and reservoirs using this to the best of your ability, and then we will fill in the remainder in class next time we meet. All right, so that's it.